Hello, everyone, and thank you for joining our second workshop. My name is Mehek, and I'm from Team Weston. So today's topic is that we'll be learning about from high performance app with state channels to building efficient Web3 products with the Yellow SDK. So let me begin by giving a brief introduction about Bisthorn. Many of you might think of Bisthorn as a typical hackathon platform, but it's much more than that. Bisthorn is a global builder platform powered by TDFI and founded on a core belief that you should be able to walk in as an idea and walk out with a business. We've had the privilege of working with major ecosystems like XRPL, Solana, Koti, ICP, and we've even hosted hackathons at the Paris Blockchain Week this year. For those who have attended our previous sessions, you already know how hands-on and insightful these sessions are. So leading today's session are two experts from Yellow, Andrew, the tech lead, and Maxim Nychuk, the head of engineering. So we're glad to have you here. So without any further delay, I would like to hand over the stage to Yellow team to begin the today's workshop with a brief introduction about them.
Thank you. Thank you for introduction. Hello everyone and welcome. My name is Maxim Nychuk. I'm the head of the technology development in the Yellow. With me, Andrew, our SDK lead SDK builder. So today we are here to talk about important one thing, the speed. Not just speed of the network, but the speed of the user experience. We want to give you and describe you the tools to build the apps that feels fast and intuitive as best Web2 applications. So we structured this workshop to be as practical as possible and answer on three main questions on the why, how, and what. So firstly, I'm going to cover why and why do so many Web3 applications feel slow and clunky for the new users. We will take a look on the core architectural problem that we are seeing. Then I will hand over to Andrew on the how. He will lead the hands-on tutorial and will show how to actually build applications using the Yellow SDK. And finally, Andrew also will wrap up with the question, what actually you can build and what capabilities we are opening to you via our Yellow SDK and Yellow network. So let's dive into the first question. So why does the Web3 so elegant and clunky? Imagine it's a fast-paced competitive game. You're in the moment when you want to take some shot or the time movement, etc. And then you see those pop-ups. This is actually I would say, interesting role, like interaction tags. It's most painful and for sure obvious and a bit sarcastic way to describe it, but it's really important for the UX of the Web3 applications. And the cool thing and interesting that its pop-up is it's not a real problem. The symptoms is much deeper. It's an architectural mismatch. We are trying to run a real-time high-speed applications on the environment that was actually never designed for speed. We are trying to have conversation on the network that was actually built to write a history on the stone. And let's talk more about the architectural mismatch. So the reason of the pop-up, the reason for the lag is because we are trying to build application using the architecture and you can see, on the left. So base layer blockchains is like central bank's vault. They're a masterpiece of the engineering, but built for the main priority, primary purpose, maximize the security and final settlements. But they achieve it by the super secure technologies like decentralized consensus. But the process are usually slow and deliberative, and it can be really, really slow. And it's actually the problem that we are trying to use this global settlement network from different chains, etc., for the tasks that are requiring the instant interactions. And Imagine you would go in the central bank on your city, etc., then withdraw $20 just to buy the coffee or lunch for you. I guess you will not do this. You will just use, I don't know, Visa and your card in your pocket. So the solution is isn't to make the blockchain less secure to make it fast. The solution is to architect your dApps or our dApps differently. We need to follow the flow on the right. It's like when you need an action, you need the high super speed response, and we need the super fast response and result. The separation of concerns is the key for us and for the Yellow network and for the narrative that we are trying to propose to you. And actually, it's what the Yellow network provides itself. So I will go high level on the layer by layer on our architecture and how it works, but then Andrew will practically more describe you in the how to actually implement it. So the base layer, as usual, is the blockchain foundation. It's jobs for security, final settlements. It's powerful, it's decentralized. It's just sometimes very slow, but I guess you're all aware what's the blockchain and what for it is. Then on top of it, we have our secure gateway. It's the set of the audited smart contracts built by us that are acts of the on-chain bridges and custodies controlled only by users. And those are wallets. And yeah, it's secure connection between the blockchain itself and the user funds. And next level is most interesting for us. It's the actual instant interaction layer, is the Yellow network. It's the where all real-time activity of your the apps is happens. It's every game move, every offer, every message, every order, for example, instantly without ever instantly executed without ever needing to wait for the blockchain for minting, etc. And the last level, it's actually your business logic. It's powerful. It's the where you build in the app. You can focus finally as you as a developer of Web3, Web2 application. You can focus on your business logic, on your business rules, on your API, on your user experience, and you are not limited to the blockchain integration to some wallets, etc. You do your own business logic. You include Yellow SDK, and voila, everything works like a charm. So that was the high-level architecture to show you and make you I would say, brief introduction on why we're actually doing all of this. It's really incredibly simple, and yeah, I guess I will hand over the casting to the Andrew. So Andrew, you can cast. I will stop sharing, and yeah, good luck with next steps.
Yes, thank you, Maxim, for answering question why. And yeah, let's jump on the section how. How to build with a Web2 developer experience with Yellow SDK. As you already know, we're spending a lot of time writing Solidity, writing smart contracts, interacting with all of it, but really we're not focusing on the our business logic, on our application, on our users who are going to interact with all of it. And here, what we're proposing is to focus on building this logic, focus more on building your own application, and let's start looking from the high level architecture of Web2 developer experience with Yellow SDK. From the first, we have our application. On the left side, you can see this box, and basically it can be whatever you want. It can be JavaScript, React, some front-end application, or some service that provides services for your users. On the right side, you can find our Yellow node. You can see about it like a ledger who provide us the abstraction from the on-chain part. And on the middle of all of it, we have our Neutralite RPC, our protocol for communication between application and Yellow node through the WebSocket. And basically, this combination very familiar for Web2 developers. You don't need to write any contract. You don't need to think about how you will connect wallet, all of the stuff. You're just focusing on the building up. Basil, What we have on the bottom? On the bottom, we have our smart contract. When we need finality or a dispute occurs, we go on chain. That's where the state channel logic lives, and a state channel, we can think about it as a private ledger between two participants. We sign and exchange states of chain, and only push the latest states, and of course, they should be signed to verify all of it to the contract. States are versioned, so the highest valid version wins, and the contract handles all this process. You don't need to bother about it. All the logic about your security and protection we have fully on the smart contract. As you can see from it, as you can see from it, it's really allow you to focus more on writing your application and not bother with a smart contract. Now let's see how to authorize to the Yellow network, how really become and work with this system. What we have? We're going to start with three entities. Our application, as we already know, it's our business logic, what we want to provide to our users. In the middle, we're going to have Yellow node, to which we need to connect to be one of the participants of the network. And on the right side, still, we have external own account, our wallet, to give the permission to user to do some operations. To start, we need to generate session key for user. This session key will sign our messages after login on the platform. After that, we need to create authorization request and send this request to the Yellow node. Yellow node will reply for us with a challenge token, which we need to pass to our external own account and sign this message. Based on it, we will receive the signature. When we have signature, we already received challenge token for our Yellow node. We need to send to verify that it's we and we want to have authorization. Okay, we verified and we have our GVT. When we receive the GVT, we can store it securely for our users, and basically this is how it's simple. Still, I know that during the coding session, during writing the code, it's not so simple as it on the diagram. But reality, and I will show you and showcase the code, it's more simple than you can think. To make this concrete, I put a step-by-step tutorial on GitHub. You can see the link on your screens right now. It's Neutralite example. And today we will cover 3 chapters. First chapter will be focused on the authentication session via WebSocket. Second chapter will be focusing on fetching and displaying asset balance. And the final one will be more about how to complete the application and make the simple transfer from one user to another user. Now, let's see. We have our GitHub. I opened the repo already. And the most interesting for you, from where you should start, is from the README. README, on the README, you can find the all chapters. It includes much more. It includes how to initialize the project, how to write the connection to the user wallet, how to do like first installation of the WebSocket connection, and other 3 chapters. As I told you, we will focusing on more on the integration to our node. Let's open it. Okay, we have it. We already saw the interaction flow and how everything should go. We will skip this part. And we will start from the implementation steps. First of all, what you will need to do in the application is install the NPM package, ERC7824 Nitrolite. It's this library. It's basically our SDK, what will provide you tools for integration. Also, what you will need to have, you can do it by yourself on your projects, or you can copy it from the example, because it's pretty common one to create a session key and private and public key. It's based on the VM. And you can see like our session key include private key and address, and address we can see about it like a public key of the user. Generating the private key is a function from the VM, and basically you don't need to end up with your own solution. You can just use what already on the market. When you have this function, it just helper function to you to use in future, and you need to store it. In our case, we're going to store it in the session key, in the local storage, where you will have as a developer very quickly access. For front-end developers, it's pretty easy to understand. And you need some helpers to remove or get the session key. After that, okay, we have our session key. What we need to do next? Next, we need to integrate whole logic of authorization. You can see everything what we import from the Neutralite. All section inside the code, I will show you a bit later, is marked by the chapter. And you can see what the methods you can use from the Neutralite. For example, you wanna to create a auth request message. Our SDK fully provides you this method, build call message for you. You just need to pass the params, and I will show you a little bit later how it's going to look like. SDK will build for you message, but will not send. You will need to send it manually by your own. If you go a little bit, if you scroll a little bit down, we can see that it's asking about EP712 domain. Right now, our Yellow node asking about type data to secure all authentication process. And basically, you will need to build on your side and collect all data for it. It will include your domain. It can be name of your application, but it should be included. Authorization scope. You can just type like yourapp.com. And one more time app name, because domain and name is a different one. And one of the most important things is session duration. And you can specify for your applications how long the GVT can live and when it should be refreshed. The minimum what you can specify is 1 hour. And for the maximum, really, I can't answer right now, but probably the standard number. Okay, how to write it? We're looking right now on the code from the React, and what we really need and from what we really need to start. We need from the beginning 2 states. First one is our session key to get it from local storage, and after that, do any logic with it. And we need to understand, are user really authenticated or not on the platform? To start working with the session key, understanding that user authenticated, we need to write this code. First one, update, we need to vault connection. For example, you already built your application. You already integrate MetaMask to your application. Nice. You have like half of the work. Now you need to grab this wallet client where you specify chain and transport. By default, it's window Ethereum and also chain mainnet. But if your application wants to support more EVM chains, you can specify any other. From this one point, you need to get the user address. It's our public address to fulfill the wallet client. This step very important for us because we will need to pass it to Neutralite in future. That's why like we set it to the state. After that, okay, we have wallet client. Let's generate session key. For session key, we have our helpers. We trying to get it from the storage. If it exists, then we just set to the session. If in local storage we already have this key, we just set it and we can work with it. If we don't have it, let's generate new one and store it. When we have session key, we trigger in the WebSocket service to connect, and we making connection to our Yellow node. The most important part that you really need to store in the local storage on the front end public and private key, but still it's a session key, it's not private key of your wallet, to prevent the regeneration of the new keys on every page refresh. And we're doing it right now only on an example. For your full application, when you go into the production, of course, you don't want to store it in the local storage. You will need to write some KMS to protect your users in the end of the day. But for example, and POC, it's pretty good way how you can promote your stuff. Okay, we have session key. We have our account with wallet client. Now let's build the message for authorization. We taking our expire time based on the constant which we specify on the top of the file, and we building our authorization params. It's include our wallet client as called account. We taking as a participant our session key address, what was generated, our app name from the constant what was set, also our scope, application. For application, when you're looking on the client side, you specify the account of the user who want to connect. From the backend point of view, you can think about as the address of your backend. You do the same logic as on front end, no difference. Just you do not need to store it in the local storage, and you can use your own public address for your backend service. And we have our create a user request message. What SDK provides, basically you take all our authorization params, put in the function what provided by SDK, and after that send to the WebSocket. Sounds not so complicated, and it's possible to use. After that, we create our authorization request, we send it to the WebSocket, and we need to handle this message. WebSocket will respond to us if there will be no errors with a auth challenge. Our SDK provides different RPC methods, and one of them, like you can see, RPC method dot auth challenge. And you can match the response with this RPC method. When you match it, you can verify that okay, it's this logic related to authorization challenge. You need to start building the verify. For verify again, you can copy a lot of information from our authorization params. Like you take the challenge response from the response in auth challenge, and you specify application, same wallet client as was during our authorization request, and same for participant, our session key. The most important thing where a lot of people doing mistake, unfortunately, is expire. Expire should be the same value as during the authorization request. For example, you specify 3,600 seconds, the same value should be located here. If this value will be changed a little bit, even for 1 second, the verification would be failed. When you have all of this, we going to create our message with type data, which we send to our wallet client. And you can see wallet client is one of the params. And it will trigger your MetaMask, for example, or any UA to sign this message. After user sign, or if you sign it on the server, you will receive a signature. And with this signature, you generate basically the verify request to the Yellow node. Again, create a rules verify message provided by the SDK. You just use a function, provide the response from your wallet, and add the challenge token. When you will send it to the WebSocket, it will respond you with another RPC method, which will include auth verify. When you will receive it, you will have your GVT, store it in local storage or session storage. You can figure out what will be the most secure place for your users. And with this GVT, you have full access to Yellow network and Yellow node. Now, When you have all of it, yeah, at the bottom you can see a lot of information about the application. We will see, and I will show you how the example works. After that, you have all of it, and you can get the balances. Let's jump on the next chapter. I need to switch back to the documentation and switch the branch to display balance. Okay, let's speak about the balances. Again, new sequence diagram. We already authenticate on the platform. Now we can ask our Yellow node about the balance. You just generate the message. We will see the code a little bit later. You send it the request, get ledger balance. WebSocket service will proxy it to the clear node. Clear node will verify, not clear node, sorry, Yellow node. Yellow node will verify session signature and will return you your balances. After you receive these balances, you can update state and UI, or if you're on the server, just update your state on the server. How looks implementation steps? First of all, on the front-end side, we will build the component to display it to the users, to the clients. And really, for all of it, we need only two params. First one is balance, second one is symbol. In our case, we expected that it will be UDC. That's why we have to fix it too. And some small HTML code here. Okay, how to fetch and display balance from the code perspective side. We will need two methods from the our Yellow SDK. First one is create a CDCA message signer. Second one, create get ledger balance message. And two types. With this function, let me scroll a little bit more. Here you can see we defined two states. First state is for balances and set balances. Second one is for just loading to show the nice loader for the end user to not see the zero number when the balances are fetching. Okay, how we automatically fetch it? We verify and we have use effect. In the React, it's pretty common when you want to do some work and automatically fetch something on the mount. We use an use effect, but it's even possible on Node or on any other stack. We need to verify that user is authenticated, already has a session key, and his account is connected. Account is our wallet client. What do you do with it? We can ask to generate, or not generate, but create the ECDCA message signer. And why this function is important? As right now, our signer and our Yellow node do not wait for your signature from the MetaMask in the standard of if 191. We remove this part. That's why we need to a little bit update the way how we sign and how we build the signature on our side. That's why you can use this function to build a session signer and pass everything what you need to have the proper signature in for your all requests what you want to send to the Yellow node through the WebSocket. Okay, we have session signer, we have wallet client. We using the function from the SDK, putting session signer as one of the params, and another one is the account, and this account is our connected one for whom we wanna take the balances. After we send the request to the WebSocket, we will expect that WebSocket will respond us with the balance information. And let's find quickly chapter 4. You can see chapter 4 is here, handle balances response. To handle it, what we have? Like again, we have our response, and inside response we have a method. And it should be equal to get ledger balances. When you receive this response, you can parse it. do logic what you need for your business. Transform because you will receive in the format like symbol as a key and the amount in the string. And after that, when you do all the transformation what you need, you could send to set it to the our state, and the state can be passed to the component. Also, it's not only about getting ledger balance. It would be not so smart to just request each 3 seconds the balance of the user. You don't want to do it. You want to have after updates in the live as you using the WebSocket. We have it. We provide in this one, and the RPC method for it is balance update. When the user balance going to update on the yellow node, the user will receive the after update, and he will receive the event BU as mentioned as balance update. The object will look the same, and that's why you can do the same transformation and reuse the same logic and set to the state. When you have it, you just pass it to your balance component, and balance component will display it on the UI. On the backend side, you don't need this balance component, and you just interact with the balance as you would like. Okay, that's all for balance display, and the final part of this tutorial is how to make the transfer. Let me quickly switch to P2P, documentation, and P2P transfer. Okay, for P2P transfer, a little bit more complicated, as you can see in if we base on the how we get into balance. But basically, what we will do is that user on the UI clicking on the button I want to send one USDC to one specific account in the network. He specifies this amount, combine builds a message, and send again to the WebSocket service. When WebSocket service send it to the Yellow node will see that transfer going from one person to another person, and will do credit and debit for 2 participants. How to do it? We will need to build a hook on the React side. And for the React side, again, the same method, session signer, as we need to sign this this message. And it's very important to sign each message what you want to send to Yellow node. It's protection to verify that it's really you, and yeah, you want to be secure in this way. To build the message itself, you will need a function create transfer message, your session signer, this destination. As I mentioned, you want to send to anyone in the network some access tokens, and you can specify this address, its public address in this place. And also you specify in the allocations. Right now we send in only one asset, but it supports multiple, and you can specify the amount. When you will send it, it will send to the Yellow node, receive you again. Let me quickly scroll to the handler part. Just quickly, it's here. Yeah, you will receive the response from the Yellow node. You can catch it here using the special function for it to show on the UI the model window. And as a result, you can notify your users that everything was successful or show the error. Basically, it's simple as it is. What else you can do with the transfer? Like basically everything what you want to send with tokens to any participant, you can do it. How application look like? Let me quickly show you. The application is Nexus. It was built to showcase all the example explaining how to build such application. You can think about it as a content application where different authors write in the content, and you want to teach them that you like some content. Let's look on the logic. The most important for you as builders it's developer console. It's the one trustful place where you should look always. As you can see, application is on, and we immediately connect to the WebSocket, and WebSocket is clearnet.yellow.com/WebSocket. And this information can be found in our documentation. It's pretty enough. The first message what we're going to receive from the WebSocket, it will be assets. It's going to provide you all assets what available right now in the Yellow node. After that, okay, we connected. We wanna to connect our MetaMask. My MetaMask here. Okay, I need to unlock it. Sorry, quickly. We have it. Let me connect it. I connect it. Okay, let's do one more time. Okay, we connect. As I mentioned before, we need to sign the authorization. You can see how it's going to look on the UI. All information is here. Who is the participant, how the challenge token looks like, and with whom we want to connect. We just confirm, and from the WebSocket point of view, we can see authorization request, authorization challenge. We send in verify, receive and verify, and we receive in our channel what is established. About state channel and channel, we will speak, and it's about the funding of your account. But next, after the channels, we can see the live update. It's our balance update, and also we asking about to confirm it one more time on the start of the application. We asking about ledger balances for our users. Okay, how to make the transfer? We can see the button support 001 USDC. I'm going to click this one, and you can see my balance was immediately updated. Transfer was completed. And that's what Maxim trying to say, that it can be really very fast. It took us, I don't know, like few milliseconds, so we can take a look on it, because it's really took us. Yeah, it's like probably 10 or 20 milliseconds. Let's do one more time. We have it. That's it for basically application and tutorial. I would recommend for everyone to go on the Neutralite examples, read it, try the simple application, try the code base, because we go through the README and live coding would be different from what I show you. But application is workable, and you can go deep dive and see the code how it's works. Now we're going to more interesting part. And advanced part is application sessions. Application sessions, you can see about it like multiple participants lobby, and this one is off-chain lobbies, where all participants can exchange movements or funds in real time with blockchain grade security, and you will not see and show any pop-ups for your end users. What's the life cycle? First in the life cycle is to create app session. When you will create the application session, you will ask each participant to sign the rules of this lobby. After that, when the session is established, everyone can interact off-chain. You can do your movements. You can do, I don't know, like real game. You can do trillions of transactions. It will be very fast. And in the end, you're going to close the session and send the final allocation to the Yellow node. You can ask me where to use it. If user interact a lot, you need verifiable state, but do not need on-chain penalty on every click, use application session. If you need to do only one transfer or two transfer, use simple transfer. Now let's speak about on-chain part. Very important question, how to bring funds to our application, how our user can top up their accounts without interacting our app or with a smart contract. For this, we have our application store, apps.yellow.com, and mostly right now is only for builders. And what they need to do, log in with a wallet, NUA, deposit and trade channel. Basically, when you're doing this action, you establish the state channel with Yellow node. as two participants and use this wallet in any application. Right now on our UI, we have 4 chains. It's Base, Polygon, Flow, and World. But really, we can support any EVM on current stage. Now let me end with what we actually can build and what it can unlock for you as a builders. Let's start with core capabilities. This provides you Web2 speed UX, chain abstraction, single sign flow, one SDK everywhere, just JavaScript. Do not forget it's not Rust SDK, and also built-in security with dispute ready on chain. What you can build: micropayments application, trading experience with millisecond matching, creator tipping as I show in the example. It can be real-time multiplayer games with like 0 fee, or you want to have very small fees. It can be like that. And also you can build high frequency, low latency dApps via the gas fee and wallet pop-ups always kill our UX. Okay, and now to end up with all of it, guys, I would like to ask you, everyone who have time at Saturday, just jump on our SDK, read Go in our Nitrolite. It's fully open source. If you can see that something is not compatible with your product, you can open the issue, we can discuss it, and really we're open for building good Yellow network, good protocol for everyone to use. Thank you.
Okay, thank you, Andrew. I guess I already answered a few questions in the chat, but I guess we can cover what was added. So what are the prerequisites to integrate Yellow liquidity layer with your dApp? But I don't know. I mean, it's mostly go in the SDK and follow the instructions to integrate it. I mean, there is no like really prerequisite or something. I guess mainly like use JS for now for the SDK. I guess that's all here, Andrew. Yeah, I guess it's all. Next one, we are building a marina and want fetch real-time tweet engagement. Okay. However, chain link function currently does not support Yellow network. How we fetch and commit of chain Twitter data, like tweet stats, into Yellow network in a decentralized and full and verifiable way. So about this one, but again, Yellow network is it's the clearing protocol, so it's for the better and faster usage of the sending funds, distribution funds, etc. So I would say if you need some extra data to store and so on, you can use, but it's not really built for it. So it's mainly to actually transfer and make the transaction super fast without paying gas and without bothering about the chains itself. So it's about it. Your business logic can have their own database, your application, etc. And then after in your logic, you need to make the payment between two users, or you want to pay from your application to another one, or user need to pay to use. Then you're using the Yellow network itself, the SDK, and the capabilities of the SDK. Hopefully, I answered this. So it's Armando, Crit and Close need to wait for the finalization. So are you talking about the obsession or the channel itself? If you can clarify a bit, would be great.
When you open the channel and then when you close for settlement.
So if you're talking about the channels that are on chain, yes, you're choosing the network where you have funds, etc. You open the channel, then it's one transaction, then you do you're using the thousands of application, making the small interactions, etc. And I don't know, in one day or in any time later, you want to do the final settlement and quit with your funds, then it's a second transaction on any chain.
But to use the channel, then we have to wait for the settlement on the initial chain, correct?
Yes, yes. For example, you're using, I mean, all your funds on the Polygon. You want to use application inside the ecosystem. You're open the channel on the Polygon, for example, you're depositing, for example, USDC, and then, I don't know, going in the merchant shop that are in our ecosystem, buying some, I don't know, t-shirts or something, paying inside the Yellow network, be zero fees, do not broadcast any transactions. And then, yeah, you are receiving your t-shirts, for example, or you're doing, for example, trading. You're opening the channel on your chain what you are using, depositing, I don't know, 100 USDC, making hundreds of trades during 1 week, for example, on the futures, and then do closing your trading session and withdrawing your funds, your profits, hopefully. So
Yeah,
yeah.
basically to answer it, also you don't want to create and close channel pretty often. You want to create it only once, top up the balance and interact with it like 30, 40 days, it doesn't matter. You're still able to withdraw your funds, but you can interact, like make really a lot of transaction. You can, for example, do the merchant, and you can think about it like grocery store, where every people come and paying through this network, and you pay the taxes only one in the end of the month when you need the penalty, and you do not need to do it each time when someone paid with Visa or MasterCard, as right now in our reality.
Oh, so does it support testnets? So we have testnets, but mainly it's for our staging environments, etc. We still, I mean, we don't have minimum deposit requirements or something, so you can try on any chain with, I don't know, half a cent or even some fraction of the cent on any chain, and yeah, it will not hurt a lot. You can use, for example, Polygon base. They are really pretty cheap and open the channel. Yeah, again, as I said, for some fraction of the funds, and then tested it, etc. Integrate, and you will see the balances, channels, etc. Okay, so yeah, it was about certificate. Already answered. Okay, let's have more questions to us.
So before we proceed with further questions, I'll just like to say that anyone who has not yet joined our community, we are dropping a link in the chat box. You can join the Telegram community. And if you have any queries further after the workshop, you can definitely put a question out there. We'll be there to answer. Also, if there are people who have not yet registered for the hackathon, you can go ahead. We are just dropping the link in the chat box. Regarding the questions that we are getting about the certificate, yes, I'll be sharing a link at the end of the workshop. So you guys can just drop your name and email and we'll circulate the certificates right after that. And also just register for the next workshop as well. We are sharing the link. Thank you. So if anyone has any more questions, you can just type in the chat or you can even ask.
Okay, cool. I
Okay, guys.
guess.
Also, if you will have any question, we have our Telegram chat for community. You can join, ask questions there, or you can open the issue in our GitHub. It's fully open source. You can go read. Maybe you will find some issue. Like really, it would help a lot, and maybe we will have your project, or you will help us. It will be very nice.
Thank you, everyone. Okay, there is the question, Other is built-in safeguards against replay or out-of-order state messages. I would say that the out-of-order state messages, it's we don't have like guard or something, but it will not be just accepted by the RPC, etc. If you would send states from your application, or your clients will send it.
Any more questions from the participants? So I guess all the queries that the participants had are already resolved. So thank you, Andrew and Maxim, for this presentation and solving the queries of all the participants. And thank you to our audience for being so engaged. So we hope this session has given you the practical tools you need to build and has solved all your queries. I guess we have one more question, if you'd like to answer.
What are prerequisites to integrate Yellow liquidity layer with our dApp? So I guess it was I've answered it before, but there is, I wouldn't say we have like strict prerequisites or something. Again, your stack should, if you're talking about technical one, just go on our SDK website. There are all prerequisites from the technology side of things. But then we don't have some more rules, I would say. You can easily connect and nodes are open. But yeah. Are you working on a quantum resistance blockchain? No.
Okay, so with this, we
Yeah,
come to
let's wrap up.
So thank you everyone for joining. Thank you, Yellow team.
Thank you. See you guys. Bye bye.
Thank you. See you.